You know, they say that I don't get my speaker's notes because of USB-C, but I'm pretty sure it's to punish me for getting here late. Just kidding. Well, I thought it was funny. So I don't get my speaker's notes. It's fine. I got a unicorn instead, and I'll take it. Hi. This is a big room. How's your conference? I heard it's sold out. Isn't it awesome? Yay. I have barely gotten to see any of it because I've been working, but I'll hopefully be here for the rest of the day, at least. So I want to talk about observability. All right, clicker. And I know that, like, most of you all know this already. Like, if there's one room in the world that is going to know all of this story, it's you guys. But I'm going to take a step back and tell it anyway, because I think it helps to contextualize why we do what we do. In the beginning, God created the heavens and the earth, whatever. Here's where my speaker's notes would have been super useful, because I wrote down a cute little, like, Bible verse. It was all quoted with, like, puns and everything, but you don't get to see it. Anyway. So, like, in the beginning, there was people who built software for users, right? We wrote things, and our users used it, and so we were highly motivated to fix it for them, because they were complaining to us. And then systems got bigger and more complicated, and we started thinking about things like tests, and a professional, like, not being crazy with people's credit cards, whatever. So, like, things changed. Some pretty scary shit. And, like, all of these changes that we made, both culturally and technically, were in response to burning problems at the time. Like, no question. And then, okay, this is where it gets a little fuzzy. I don't know, Steve Jobs and the worm, and this is why women have pain in childbirth. I don't really remember my Bible. Suffice it to say, we have been trying to get back to this ownership model of code, like, for as long as the DevOps/SRE revolution has been around, right? For the past 15 years, it's all as trying to keep all the things we've learned over the last, 2 decades about reliability, about making things safer before they fail, about resiliency. We're trying to keep all, and all the deep expertise that we've learned. We're trying to keep those things, but get back to, like, that era when you wrote it, you shipped it, you owned it, right? Because, and this is important, because that makes it better, right? Not just the software, although it definitely does. It's better for the humans, too. It's better when you have ownership and autonomy. It's better when you can exert creativity over your sphere of the world. It's better when, these feedback loops, even though there's a little bit of, opsy masochism sprinkled in there somewhere, even though there is that heritage, it is better. It is better for us. So it's funny to me that, like, all of the things that I've been caring about for my entire career, like putting software engineers on call and, testing in production, all this stuff, I never thought of them as having anything to do with observability, but increasingly it seems like they do. And this is because it's all bound up in this model of software ownership. And I've been thinking about, like, what makes software ownership, right? What is it? To me, you boil it down to these 3 things. You write the code. You have at least the power to ship your own code, to deploy it and roll it back, and the ability to debug it, understand it live in production. If you don't have any one of those 3 things, you do not have software ownership, right? Ops people who don't write code, not software owners. Developers who are in environments where they're constrained, they can't deploy code, those are not owners. And developers who are not expected to support the full life cycle of their code, they're not software owners. So, like, the implementation details can be, let's just leave them completely fuzzy for now because, nothing is mandatory, blah, blah, blah. But I think that it's important to crystallize this in our minds. This is what we want because it's better. Which I guess kind of in this metaphor makes DevOps into Jesus and, like, the second coming of, but let's not get into that. That's fine. A thing that I started realizing just a few months ago is that observability, do I have this in a slide? Fuck, I don't. Observability is intimately tied to the success of you putting software engineers on call in ways that are perhaps surprising. But before I go into that, I do just want to give you a little bit of my background so that you know what my biases are, right? Now, obviously, in my mind, I started solving this problem because it was annoying me, and I finally found the solution, so I wanted to give it to everyone. I also live in a capitalist society, and I, as much as any other human, have motivated reasoning, whatever. I am a software vendor, so you should take everything that I say with some, scoopings of salt. It's like, I just want to disclose that, I've made my career out of being the first infrastructure engineer who likes to come in as soon as a product seems to be about to take liftoff, and I love that. I love that. I love taking something that kind of sort of works, but like people are excited about it and interested in it, and I love just making it real. So that's what I've spent my entire career doing. I did not intend to be a CEO, but shit happens. And that's my blog. And if you have the book, I brought a bunch of unicorn stickers with me to fix the cover, so see me afterwards. They won't let you have, O'Reilly won't let you have mythical creatures. Stupid. Oh yeah, and this is how you know I'm from ops, because that's basically how I feel about software. The only good diff is a red diff. And interestingly, although I've been on call since I was 17, right? I've always loved operations because that's where, the beautiful theory of computing meets reality. I've never liked monitoring. I've always kind of actively loathed it, honestly. Can't really explain it. I've always been a databases person. But it definitely informs the way that I think about systems and that I think about what we do. Like, we're not a monitoring company. And sometimes this does manifest where I will say something really stupid about how monitoring is, and people just be like, dude, if you've been paying attention for the past decade, you know this is not how it works. Happens. And monitoring is very important, and you should do that. This is my thesis for this talk. In my experience, when relatively healthy teams try to move towards a software ownership model and they fail, it's usually because of an observability gap. And I say this because, culture is one of those things that it is necessary but not sufficient. Just like just about anything else, right? Things have to be acceptably good for you to do something, and they don't have to be the best in the world. And I have definitely been, my bias, my privilege is slanted towards, I've always been on pretty functional teams. So there are a lot of ways that people with scars will just be like, oh, no, but this could happen. And I'll be like, oh, yeah, that super could happen. Not in my experience. In my experience, healthy teams. So I have both been on these teams that have tried to make this leap. I have been leading these teams that have tried to make these leaps. And I have both succeeded and failed. And sometimes I have both succeeded or failed and then later succeeded with almost the exact same team, exact same company, and like exact same tech stack. So clearly it's not, it's not just those things. And when I say the observability gap, I keep wanting to put this thing down, don't I? I don't mean just like the way that some people have been defining it for years, where it's just, there are 3 pillars of observability: logs, metrics, and traces. That definition, to me, is so meaningless, so useless as to be absolutely meaningless. Meaningless is useless. It doesn't mean anything. You're just making it a synonym for telemetry. I think that observability has a real meaning that we are just beginning to explore because reality is demanding it. We need new technical terms to describe intensely awesome and weird new technical concepts. And if we don't have the language, it makes it really hard for us to collaborate and teach each other about them. So when I talk about observability, I am basing it off of the control theory definition, which is observability is a measure of how well your internal states of the system can be inferred just by looking at the outputs. The observability and controllability, blah, 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 blah. So I love this definition. And the more I started thinking about it, the more I was realizing that it has a lot to share with us. Because what you're basically saying is, all these best practices that we've been talking about for years about how SSHing into machines is an anti-pattern, right? About how, all these things. If you're doing things correctly, you should be able to, as a software engineer, remember we're talking to software engineers mostly, you should be able to ask questions via your instrumentation. Your instrumentation is the lens into your entire system. In other words, can you understand what's happening inside your systems and your code just by asking questions from the outside? Can you debug your code just through your instrumentation, to some estimation of just. And this is a spectrum, right? But using this definition, working backwards from it, it takes us to some really, really interesting places. Oh, key, without shipping new code. Anybody can ask new questions if they ship new code, right? The hard part is finding that level of abstraction and detail where you can answer almost any new question without having to go, let's capture this detail. You have an observable system when your team can quickly and reliably track down any new problem with no prior knowledge, without being able to predict that it was going to happen. Let's contrast monitoring and observability just a little bit. One of the most interesting things is the perspective, the question of perspective. Who is doing the observing? And for monitoring, this has traditionally been, ops people sitting over here looking at the system and wondering when that's going to tip, when the disk is going to fill up, all of these things. And so it deals a lot with aggregates, right, that lose resolution over time as they age. Observability, that third-party perspective is almost useless to someone who's developing software. What they need is from the perspective of the code. What is the experience of that request or that event, right? It's the difference between looking outside and going, how big is that building? And going inside the house and going, there's drawers over here, It's software explaining itself back to you from the inside. And I know that not all monitoring is black box monitoring, but I do feel like they're kind of grouping, as rough groups, you can kind of say that the monitoring stuff is black box because it's external and observability is much more internal. Example question, what is the capacity? When do I need to increase it? Versus observability. And obviously when I say developers do this, ops do that, whatever, you guys know what I mean. Everybody does everything, it's fine. But these also roughly correlate with known unknowns and unknown unknowns, right? There are the known unknowns. Who here has not had to write a Nagios check? Oh, yeah, that's a sad question. But that is the definition of predicting in advance what's going to fail, write a check for it, and then wait to get paged, right? The most depressing part about being an ops engineer for the past 15 years. Versus observability, where it's I don't fucking know. Sorry. I don't know what my users are going to do tomorrow. I have to write some tooling that will let me explore what they're doing and understand what they're doing, whatever it happens to be. And when you think about it, we have been building for 20-odd years. We've been building tools for people on the operations side of the house, and we have not really been inhabiting the perspective of the code itself. APM has come up recently, New Relic, which is a huge step in the right direction. My main quibbles with it are about, we'll get to that later on. That's the right direction, though. But why now? Why is it changing now? And by the way, for software engineers who have grumbled in the past, by putting me on call, when they're really, by putting me on call and expecting me to do all this, you're just asking me to do 2 jobs. They have not been wrong, right? If what you're giving them is a bunch of Ganglia or Prometheus dashboards and telling them to understand all their shit and how it interacts with all the infrastructure and deploy, that is the second job. It is, because it takes so much intuition, scar tissue, history, context to be able to look at one of those dashboards and draw any straight lines between that and what's happening in the code, right? It's really hard. It takes a lot of time to develop that because we don't notice that we have it, right? If we've been doing ops or something, we don't know that we have it. It seems easy. It's not easy. It is 2 jobs. It doesn't have to be 2 jobs, which is what we're talking about. How do we make it not 2 jobs? How do we make it completely reasonable and table stakes to expect software engineers to understand their code and explore it in production? But why now? Well, first of all, there's Moore's Law. Super helping a lot. Storage has just gotten a lot cheaper, right? So we don't have a lot of the early decisions that were made about how we store bits on disk, like the metric, were basically just how can we make this as cheap and small as possible, right? Like the metric, we're just going to throw away all the context of this request, reduce it to a couple of numbers that aren't even correlated, right? And that was absolutely a decision that was made out of scarcity. The other reason is complexity. it is becoming mandatory. It is becoming mandatory because we have built these systems that the feature sets are so rich, they're increasingly platforms. A platform to me just means it's any system where you're inviting the user to put their chaos in your shelf. The infrastructure itself is so far-flung, and Kubernetes is often a tipping point for people. Microservices is often a tipping point for people. But a lot of people are reaching this tipping point where their systems are so complex, the range of possible answers to any one question has become so large, and they're ephemeral. They can't use their intuition to just reason about it in their head anymore. Things are blipping in and out of existence. So they hit this cliff. They hit this inflection point where their old tools no longer work for them. Their old way of doing things no longer works for them. A lot of times, this is when they start having to put software engineers on call, because if you aren't spending your days heads down embedded in the code, it's really hard to deal with it, right? This was indirectly what led me to create Honeycomb, was the absolute catastrophe that parse was. Now it's been shut down, I can absolutely say that. Complexity is exploding, and our tools are still designed for the LAMP stack, where you could look at a dashboard and in a glance at least know which component was at fault. With questions that we get these days, I often feel like, I have all these tools that give me answers to questions. That's great. If I knew what the fucking question was, then I could answer it. I don't know what the question is. All I have is a bunch of kind of not related to each other reports of something that might be wrong and they might be on crack. I don't know. It's really frustrating. So here's a graph of complexity I drew for you as a music major. But we all know this. We all know that it's going up. Here's a graph of a LAMP stack, and here is parse a couple years ago. That blob in the middle there is just a few hundred MongoDB replica sets. And JavaScript, where we just invite our users to write their own queries and code and upload them to our servers, where we will just magically make them work right next to everyone else's, and there will be zero codependency problems. Never do this, by the way. Never do this. But it gets better. Increasingly, our systems look, that's the national electrical grid, right? That's what our systems increasingly look like. And if you're trying to fit that into your head and reason about it, you're doing it wrong. It is increasingly an anti-pattern to me when you ask someone a question about their infrastructure and they just close their eyes and rattle it all off. We can't really lean on that anymore. We have to get used to dragging all of this knowledge out of our brains and putting it in tools, which has the additional benefit of then other people can use it, which is super cool if you like vacations or plan on dying, not to get too dark. But National Electrical Grid, if you think about your systems this way, what do you do differently? Well, some problems that you have are only going to be hyperlocal, right? A tree fell over on Main Street in some town in Iowa. You're not going to predict that, right? You just need a way to quickly identify it, see, and then maybe zoom out and see if this is likely to happen again, if there's a local storm in the area or just a rotten tree, right? Some problems are hyperlocal. Other problems you can only see by zooming out and getting really big and systemic, right? Like if, say, every bolt that was manufactured in 1984 is going to rust twice as quickly, You're only going to see that, and it's going to be hard to find that outlier too, right? Which means that you need a lot of context in your events. You need as much detail as possible for every single. It's almost that the numbers themselves, the numbers aren't important. The connections between the numbers are important, because that's how you can find. That one statistic that just happens to be incredibly high or low for every request that is erroring, right? This is why I'm so anti the metrics model for storing data, because it strips away relationships. That and cardinality, which fuck that. But sorry, God, I'm swearing a lot. I'm very much trying not to. But computers, right? The world is shifting from, a world of mostly unknown unknowns and predictable failures to a world where failures are not easy to predict. I'm flying blind here. I have no idea what my next slide is going to be. So this, to me, parallels the shift from monitoring to observability, right? From waiting for the problems you know are going to happen eventually to happen, to being very resilient and ready and waiting for whatever to happen and dealing with it. A lot of people feel like they're bad at debugging. A lot of people feel really at sea when you put them on call, or they're terrified. And I try to tell people, honestly, you're using tools that were not built for what you're trying to do with them. It's not your fault. We can do better. That, and we've just been really bad about having designers on developer tools, or like building for human beings instead of robots. I think we can do a lot better there, too. But like, these are the major trends, right? Monoliths, microservices, the database. Remember when we just got to pick between Postgres and MySQL and go home? Good times. Now we all have polyglot persistence for really good reasons. We can now do way more powerful things with data. And for younger companies, especially, this is likely one of your competitive advantages. It's not like we all adopted MongoDB for the fun of it. No database people here? Oh my God, I thought that was solid. Single tenant to multi-tenancy. A lot of categories of problems are now becoming platforms, right? Because it's boring to solve the same small problem over and over and over. You should give someone else your money so that they can solve it as a category solution. But this also means that your infrastructure now is reliant or loosely reliant on a lot of things that are outside of your visibility and control. So, you cannot reason about it, and it is often harder to find out where the problem is and what the problem is. This is the dawn of a new era of distributed systems. It's super fun. Also fine. It's all fine. It's definitely not fine, actually. Your system right now has so many catastrophic states existing that you have no idea about. And probably some that you do. Anybody who tells me that their system is completely up just doesn't want to think about it closely, or their tools aren't good enough. It's one or the other. I feel like when it came to debugging, it used to be that there were pretty big categories of problems that it could be. It would be a database problem, like a slow query or whatever. But with distributed systems, it's more like you have this infinitely long, thin tail of things that almost never happen. But once in a while, they do. Which means that staging is useless. Absolutely useless. This is worse than useless, actually. It's a giant sink for your time and energy and life force that gives you nothing but disappointment in return. That's my mild opinion. Which is why, see my shirt, I'm a proponent of, I say this somewhat facetiously, right? When you test in production, you are not therefore implicating that you do not test before production. Hi, Heidi. She believes this too. Yes, you should test the basic stuff before prod. But we all have a very scarce number of engineering cycles. And what I see over and over and over is people continuing to just try and get staging to match productions, trying to get it up to date, trying to work it into all their workflows, trying to this and this and this. Instead of kind of going, we're going to test as much as we can before production, but there is a large category of stuff that is absolutely impossible to test anywhere else. So instead, we're going to take some of those staging cycles and invest them in production, in hardening it, in making it resilient, in canaries, in safe deploys. I'll just start with fucking deploys that aren't terrible. I mean, God, I feel like release software is the single most ignored and yet the single most important software in every single company. It makes no sense. Making it so that you can fail more with users noticing less, right? Affecting them less. Have a canary that rolls out to internal users first, and then promote it to beta users or something. Or like Facebook would always roll it out to Brazil first. I don't know what Brazil ever did to them, but but like 10% of Brazil, and you have your robots monitor like key metrics for a while, and then you automatically promote it. You can have many versions in flight at one time. If you have the tooling, it's not scary. Anyway, that's how I feel about testing in production. That it's impossible to not do it, and it's better to admit it and invest in it. You can think of it as experimenting. Is that a better word? Like, there are huge categories of, I'm not going to get too derailed in this, I promise, but there's also you can't predict what your users are going to do, right? Also, there are a lot of categories of bugs that you can only ever find at scale. You can only find if you have real users talking to real data across real networks. Okay, I'm stopping now, I promise. And don't do it blind. This is another place where the reason this is so scary is often that observability gap, that people don't have confidence that they can know what's going on. The fact that we still ship code and wait to get paged kills me. We should not be doing that. It should be muscle memory for every single one of us. You ship something, you go look at it. Did what you expected to happen actually happen? Does anything else look weird? I swear to God, if we all just did that, 80–90% of all problems would never even be noticed by users. And yes, someday like AI is going to do all this for us, but right now that is a false hope. Unless you're at Google. It probably works at Google. Anywhere else, do not listen to the Kool-Aid. Right. Remember what I said about not being able to see my next slide? Anyway, so observability is the missing link for a lot of these things. It also is a very good whiskey, just unrelatedly. It's one of my favorites. So all of this probably sounds completely reasonable in the abstract, but let's dive down and look at some actual examples of the kinds of problems that I'm talking about. I feel like this is helpful. Let's take an old school. We've all debugged some variant of this. Photos are loading slowly for some people on your website. Why? And this is in a LAMP stack environment. What would we expect to see? Well, can you guys read that at the back? Yes? No? Yes, thank you. Database is getting slow. There's mirrors, something's timing out, right? You can skim through these pretty quickly. That makes them really great things to monitor for, right? All these known unknowns, yes, monitor for them. Cool. Characteristics of these systems, very friendly to intuition. Dashboards are great. The health of the system more or less accurately represents the experience of the individual users, right? So if you have an uptime percentage of 99.8, and 0.2% of the time, somebody is getting an error. Very straightforward. Best practices. Every alert must be actionable, right? This is the key, monitoring insight. Everything should be actionable. Monitoring is so biased towards outages and errors and things being wrong, right? Observability isn't. It's often just I need to understand this. Maybe I want to understand this so I know if it's worth writing this other thing today, right? With monitoring, you should maintain a runbook because these things are predictable. Again, with observability, you can't maintain a runbook for things that you don't know are going to happen. Proactively notify engineers. One of the things that I always remember being told and telling people is you should never have to look at graphs unless you get paged. You shouldn't have to sit there, with dashboards up. It should inform you when there's something wrong. And that made sense back when we could round nothing's wrong up to 100, right? But now it's there are lots of things wrong, and we've grown to know this. And if we literally tried to alert on every error, we would all just die. So we don't. We choose a reasonable threshold, right? And we look for a reasonable, that seems about okay, which is why we still spend so much time curating alert thresholds, right? But that's fine. That's the best we can really do. You should notify engineers when there's a failure big enough to interrupt them. And sadly, this isn't really so much a best practice as an unfortunate reality, is that we still rely so much on clusters of signals to inform us about what is actually wrong. Oh, these half dozen things are going off. It must be Redis. Sorry not to pick on Redis, although it deserves it. All right, so let's look at the same question, but these are, from a microservices, these are actually real outages that were taken from both Instagram and Parse. Would you want to get paged about any of these? Oh, I have more. What am I supposed to monitor for? Some of these aren't even really bugs. Yeah, I can literally keep going all night. That was one of my favorites, the first one, where somebody came to me and was like, push is down. I'm like, push is not down. I'm getting pushes right now, and there's a queue, therefore push is not down. And they're like, no, it's down. They come back the next day. Push is still down. People are really angry. I'm like, finally they convinced me to go look at it. And I look at it, and after a while I realized that we were using round-robin DNS for all of the Android push notifications. So the way Android pushes work is they have to keep a socket open to the server at all times. Yeah, I know. And we're using round-robin DNS to load balance these things, and we added some more service, and we exceeded the TCP packet size, or UDP packet size, which is fine, right? It's supposed to fail over to UDP, which it did for everyone except for those coming through a particular router in Eastern Europe. Again, what do you want to monitor for? You can't. You just kind of have to embrace the hilarity of the fact that you can't predict where anything's going to happen. Is that all that I have? Right. But these are all very much unknown unknowns. That may have never happened before, probably will never happen again. Often we'll add a monitoring check so that if it does happen again, we find it immediately the next time, right? But they are also the overwhelming majority of all the things that you're probably going to have to worry about for the rest of your career. So, characteristics of these systems. Mostly unknown unknowns. This is like the caveat, if you're at a pretty stable system where you've done your jobs, like there are places who will not invest into enough tech debt cleanup, et cetera, that you don't actually get ahead of the alerts, which just sucks and you should leave. But like assuming that like you have basically a functional system, you shouldn't really get paged about things, because if you get paged and you know what it is, then you should have remediated it or like fixed it, you know? Many components in storage systems, you can't model it in your head. The hardest problem is often which component to find. And I want to flag this last one, especially from a software engineer's perspective, the health of the system is irrelevant. Doesn't matter. All they care about is the ability of every single individual request to get the resources that it needs to complete, right? Like imagine if you're on AWS and one AZ goes down and you have balanced your traffic across 3 like you shouldn't notice, right? Your system can be 30% down, and neither your user shouldn't notice and your engineer shouldn't have to get woken up. From the perspective of the code, everything is A-OK. Now, obviously, eventually, like someone from Infra might want to, check in on this, but that is a different set of problems. Those are monitoring problems. For the infrastructure, we are talking about for the software. So, known unknowns, yeah. I also like to think about this as like the process of moving things from the pile of engineering problems over to the pile of support problems, right? Like at Parse, a few times a week, someone would come to me like, Parse is down. Disney says that Parse is down. I'm just like, Parse is not down. Like, look at my wall of dashboards. They are all green. Now, maybe Disney does 4 requests per second, and we're doing 100,000. Well, it's never going to show up on my time series aggregates. So turning that from an engineering problem where we're just like, start digging, to being able to slice and dice and like return an answer quickly and reliably is really, really nice. Engineering problems require creativity. Support problems do not. And this is why it's becoming a more and more fun time to be an engineer, too. Yay, harder problems, more creative thinking. Worth a shot. So, observability for software engineers, like this is my pitch of this story, right? And now I want to go into the details. All of the things that I think make up the kind of observability that makes it so that you can put software engineers on call and not feel like an asshole. And if you're looking at this, and if you ever use Honeycomb, and you're like, boy, this looks suspiciously like a list of things that Honeycomb does, well, you're not wrong. We have the advantage of being a young company. We got to make all those decisions right the first time. I guarantee you, every single one of these things, you're going to see more and more and more and more and more people adopting them, and they should. And if you start one, you should too. And if I don't convince you by the end of this talk, see me after class. Hunting unknowns, blah, blah, blah. That's kind of the same slide, isn't it? So this is an instrumentation game, 100%. And this is good. Let me do a time check. What, 15 more minutes? Okay. I'll try and leave a little time for questions. This is absolutely an instrumentation game. And as an industry, we are just beginning to level up and have some generally shared upon conventions that you can learn about how to instrument code well. This has been like a dark art that's been passed down from like senior engineer to junior engineer like repeatedly, and yet there are these families, these lineages, generational trees, right, of people who came from Google learned things this way, then they blended with people who came from Oracle who did these this way. It's super interesting. I hope somebody does like a social science study on it someday. But it's all about making your software explain itself back to you or your future self or some naive user. The right level of abstraction is absolutely key. I'm going to skip past this, actually. But the place to start is wrapping all network calls with whatever it is that you're shipping over the network, whether it's a database query, a request, or whatever, and the timing information. And just, if you do nothing else, always store that. Events, not metrics. And when I say metrics here, I'm not talking generally metrics. I'm talking about the data structure where there's like a number, stripped of all context, and then you add back some tags so that you can group them. I am violently against this data structure. It's my least favorite data structure. Because context is the most important thing in the world when it comes to debugging and understanding your systems. I really prefer very wide events, and we're talking like hundreds of dimensions, right, as a data structure, so that you're saying all these things were true at once, all these things happened in this event, and it makes it's so nice for debugging. Tracing, I think of as just another event. It's just a visualization that you put on top of it. Tracing is absolutely key. I feel like observability for software engineers you can serve up on a platter as events and traces. Boom, that's all you need. Context, structured data. Raise your hand in shame if your company does not structure its logs. Oh, sweetheart. Oh, well, I'm happy there's just a few of you. Yes, progress. Hilariously, the two greatest signals that we have found at Honeycomb about whether or not a company is going to be a good prospect for us are, do they put their software engineers on call, and can they summon the engineering discipline to structure a fucking log line? You would be shocked and appalled at how many people cannot. But that's because we're still kind of early in this push, right? It's going to get easier and easier. It's going to go down market. It's going to be fine. Cardinality is another beef that I have to pick with metrics. And I know that I think Prometheus and some of the more recent ones have added the ability to do some better stuff here. But when you think about what is important in data, what is identifying, what is interesting, do you ever come up with things like AWS region? Not really. That's a bad example, maybe. But when I say cardinality, what I mean is this. Imagine you have a table of 100 million users. The highest cardinality would be any unique ID, like your social security number or tax ID number. Lower, but still quite high, would be last name or first name. Very low would be gender, And lowest of all, presumably, species equals human, right? So like species human, not super useful for identifying outliers and problems in this data set. Super useful, things like request IDs, things like UUIDs, things like shopping cart IDs, things like raw queries, things like, all these things. I want all of it. I do not want to have to make trade-offs. I do not want to have to choose, and I want to be able to break down by 1 in, 10 million IDs combined with, 1 in a million. I want that all. And it's not impossible. It is actually easy. We have done it. High cardinality will say, so there are so many problems that are hard if you do not have a tool that can support high cardinality. And they just become as easy as breathing if you do. Like the Disney example. Around the time that we got acquired by Facebook, I was coming to the horrified conclusion that we had built a system that was basically undebuggable by some of the best engineers in the world. And as soon as we got some of our data sets into Scuba, any Facebook people here? No? Yay, cool. As soon as we got some of our shit into Scuba, we were just like, break down by Disney, then break down by, endpoint and latency percentile. Oh, here's what they did. It became that easy. Like, it stopped being an engineering problem. It started being a support problem. Boom. Ever since then, I've been very prejudiced against metrics. High cardinality is not nice to have. This is a necessary tool. I also hate metrics because they do so much right-time aggregation. which means, like, if your goal is to be able to ask new questions, you need access to the raw data. If all you have is aggregates, those are the only questions you can ask. You can't ask any new questions except the ones that you predicted and aggregated by. And if you aggregate at read time, then you can just compute things like latency percentile when you're reading. Also, events tell stories. Like, this is how our human brains work. It's so funny watching, ops people who have 20 years of working with metric stuff try and fit their brain to the very straightforward and simple just asking a question of events. And watching software engineers who have not spent this long using ops tools, it just seems natural to them. So I think that ops is going to go to events too, but I think it's going to be longer just because we've taken such a detour. And if you structure your data at the source, well, I've heard it called logging with intent, and I like that because putting just the teeniest amount of thought into it there means that you don't have to write regular expressions for the rest of your life to get any useful data out. Like, strings can just die in a fire. Oh, and when I say event, I mostly just mean a structured log line that doesn't actually get flushed to disk. I don't like the baggage of logs. Dashboards are very nice for some things, not for debugging. They are bad for debugging. They will work against you when you're debugging because we tend to work with the data that we can see, right? So if something stops shipping its data source or whatever, and we can't see it, it's going to be a long time till you find it. Also, every dashboard just kind of is an artifact of some past failure. Like, what do you do in a postmortem? You're like, well, let's create a dashboard so we can find this immediately the next time. Now, okay, fast forward by a year, and how many dashboards do you have? Do you find anything immediately the next time? No. No, you do not. Also, they jump right to answers without stopping at the question, right? The process of formulating a question is so critical. This is what makes you a better engineer. Just eyeball scanning, looking for spikes, does not make you a good engineer. And it's lazy in the bad way, right? Front-loading asking a question and interrogating your... I think of this like BI tools, right? In BI, they do not have a bunch of dashboards, and whenever a user does something, they go flipping through their dashboards to see which one matches the behavior. That would be insane. They go to their data set, and they ask a question of the raw data, and based on the answer, they ask another one, and they go where the data takes them, like breadcrumbs, right? That's how you interact with data. That's how you interact with the system, not scanning with your eyeballs. 5 minutes, got it. And dashboards that let you interact with them are exempt from my rage. Raw requests are necessary to ask new questions. And aggregation is bad because aggregation is a one-way trip. Once you have smushed all that data together, you can never unsmush it, right? So you probably want a window of time where you keep the raw data and then you can age it out, because after that you're just looking at trends. There's a limit cost-wise to how much you can store. Aggregates destroy all your precious details. You must be able to ask new questions. Don't destroy it. You just can't you cannot hope to find these problems unless you're capturing the detail in a way that you can explore it. And these are the technical, these are just what needs to exist in order for you to do that. I'm open to any other experience that anyone's ever had, but I've never heard one. So some examples of things that you can just answer really quickly by exploring. You know how you go on call, you put someone on call for the first time, and time elapses, and then they're like, oh, there's an error. And you're just like, yes, grasshopper, there is an error. It's fine, it happens all the time. Well, what if we didn't have to do that? What if we could just go, yeah, let's figure out what it is, right? What if we rewarded that sort of exploration and curiosity and just playing with our... I really feel like we have to tap into people's sense of play, right? The dopamine hit that you get from finding something before it fucked your users, right? Or just finding something that nobody knew existed and fixing it. That is some powerful stuff. But in the end, one of the reasons that I don't like the top-level aggregate, health of the system thing is because users don't care. Your users do not care what the health of the system is. All they care about is, are the requests succeeding? Services need owners, not operators. Observability is for generalist engineers who are writing code and shipping code and trying to understand it. Instrumentation is the most important part about building software. And the reason we do this is because it tightens feedback loops, it leads to better quality systems, it leads to better work-life balance, more sleep, and probably you'll just be prettier. I don't know. Observability-driven development is the goal, and watch it run in production. There is no substitute for becoming literate, for knowing what normal looks like. If you don't know what normal looks like, if you aren't playing in your systems in the regular, you're not going to be able to understand them when they break. So, in conclusion, Sparta! That's it. Oh, and the reward. I should probably mention this. Every time I've ever seen people implement this, the reward is that you get to delete like 95% of your paging alerts. If you're no longer relying on these clusters of paging alerts to signal to you that some other unrelated component is wrong, and if you have the ability to actually go in and understand things, you can delete everything except for the high level. I recommend errors, latency, request rate, and then of course some end-to-end requests that traverse the key parts of your stack that earn you money, right? Just have a couple of those, and maybe that for each service level, depending on how big you are. That's all. And the reason we don't do that now is because we don't have the ability to reliably jump in and answer any question quickly. That's all it comes down to. When you can do that, you get paid less, way less. Thanks.